Hi girls, notes for 9.3, we're going to derive or come up with the sine rule. So we're going to come up with kind of a relationship between the sides and angles of a triangle that's not a right triangle. So previously, you know, when we used sine, cosine, and tangent, we had to have a right angle triangle like in 9.2, but we don't now. So all these angles are not right. I'm going to call it triangle A, B, C. And when you name the angles of a triangle, they have to be capital letters, and the sides are the lowercase letters, so little c, little b, and little a. And that's just a mathematical convention that we absolutely have to use. All right, so I'm going to derive this or come up with this relationship. I'm going to go quickly. I'm going to drop a perpendicular, so from any angle, but B looks nicest to me right this minute. I'm going to drop that height, and I'll call it h. That's how long that height is. Remember, this is how long that side is, that's how long that side is, that's how long that side is. I'm going to look at this and say, okay, let's say I have angle A, and I want to say what the sine of angle A is. Well, remember that it's opposite over hypotenuse, so it's h over c. And I'm going to say what the sine of angle C is, and the sine of angle C is opposite over hypotenuse, h on A. And that means that in this equation, I can get h equals C sine A, and in this equation I can get h equals A sine C. All right, so now I have two things equal to h, and now I'm going to set them equal to each other. So a simultaneous equation where these two have to be equal to each other. So I get C sine A equals, you can put brackets if you want, you don't have to, A sine C, which means A, little a, the side, over the sine, whoops, of the angle is equal to, take that over there, side C over sine of angle C. And I could go through this one more time with a different line, maybe a different height right there, and I'd get that that's also equal to B sine B. So we use this rule, and this is the sine rule, which you will never have to derive, but it's the sine rule to find sides and angles of a triangle when it's not a right triangle. So I cannot use SOHCAHTOA anymore because I don't really have a hypotenuse in this thing at all. Okay, so here we go. Let's do an example of what I might use it. So I'm going to use a sine rule to calculate these lengths. Well, this is the side opposite that angle, and this is the side opposite that angle. When it says go to one decimal place. So I'm going to go x over sine 80 degrees equals 16, sides are on the top, angles are on the bottom in this case, sine 40 degrees. So x equals 16 over sine 40 times sine 80. So just grab my calculator, and when you stick that in your calculator, you'll get that x is approximately 24.5. So this side is 24.5. Easy as that. All right, let's try to do one more example before our time runs out on the video. This one says calculate this, oh, I said with a twist. It's a little bit different. It says calculate the side lengths in this picture. I'll just get us geared in here, okay? Correct to 4 significant figures. I don't really care about that. We'll do decimal places, but it says calculate the side length labeled y. Well, I need, if I'm going to calculate y, I need that angle. I can't do the sine rule without that angle. So the first thing I have to do is find that, and that just takes remembering that a triangle has 180 degrees, so I'll take off 65, and I'll take off 75, and I'll get 40. Okay, easy enough. And so I do y over sine 40 degrees equals, remembering the sine rule, 16 over sine 65 degrees. So y equals 16 over sine 65 degrees times sine 40. So go over there, work it all out. That is approximately 11.35 meters. I guess we're meters. Okay, that's 4 significant figures. 1, 2, 3, 4. All right, cool. I think I'll end the video and start a new one.